All right, video number 2 here, covering what's called the triangle inequality theorem. All right, so here it is in the flesh. It says, oh, not that one. There you go. It says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. All right, this is just a really interesting idea for the existence of a triangle. Okay, so here's your picture, and again, you have these three inequalities, right? This is adding any two sides to be bigger than the third side. But really, when you do these problems, there's really only one situation you have to choose or check, and that is you must check, is the sum of the two shorter sides greater than the longest side. That's really the only situation you have to choose, right? So is the sum of the two shorter sides greater than the longest side? Again, triangle inequality theorem. Big idea. All right, so let's take a look at a couple problems here. So it says, which of the following sets of segments could be the sides of the triangle, right? So what's kind of cool is that it does have this Desmos activity down here for us to look at, but you'll notice in the first set are three lengths, and I'll write them down in least to greatest order: 18, 19, and 40. All right, so let's get on to Desmos and check it out. I apologize, it means Savas, right? So let's get there. So when we come up here, oh yeah. Oh, sorry. Okay, so if we take a look here, right, notice that when you try to bring these together, they're never quite going to touch. Even if you bring it all the way down, they're just short. You can go on the other side, right? There is, oh, you can't take it off, though. Don't do that. There is no connecting these sets of sides. And if you look here, right, let's go back to our problem, right? I wrote down those sets of sides to show you that the two smaller ones, which are 18 and 19, if you add them, 18 plus 19, that is equal to 37, which is not greater than 40. So this shows that the two sides, the two shorter sides, are not greater than the longest side, the sum. So therefore, this is not. So no, the first one cannot be. All right, the second one we have is 33, 37, and 66. So now let's go to Savas there, and let's take a look. So over here, if you look now, we're in business, right? Because again, the 33 and 37 could be apart, but if you bring it down and bring it down, they will eventually connect somewhere and create the triangle, right? So if you compare the two shorter sides, the sum of the two shorter sides to the longer, right? If you do 33 plus 37, that is 70. And 70 is bigger than 66, and you're good. So this would be a triangle, yes. Okay, one last problem here, and then we're done with this section. Okay, it says a triangle has sides. Give me a second. A triangle has sides that measure 11 centimeters and 16 centimeters. What are the possible lengths for the third side? So when you do this here, I'm going to label, right, just like the triangle inequality theorem, I'm going to label XA, I'll label 11B, and 16C. So based off the theorem, we're going to check three inequalities. First, we're going to check, is A plus B greater than C? Is X plus 11, so this is the first one, is X plus 11 greater than 16? Well, let's solve this for X by subtracting 11 on both sides. So this is saying X must be greater than 5, okay? All right. Number two, let's check to see if BC is greater than A. Is 11 plus 16 greater than A? Greater than X, I'm sorry, X. Well, 11 plus 16 is 27. 27 must be greater than x. So if I reverse this, putting x first, this is saying x must be less than 27. And then if I do the third situation, now let's do a plus c greater than b. X plus 16 must be greater than 11. Well, if you subtract 16, x must be greater than negative 5. This one doesn't make sense, right? They must be positive. So these two are going to contribute to the range of x values that you can be. The lower limit is 5. The upper limit is 27. We're going to write this as a double inequality. So 5 is going to be less than x is going to be less than 27. And this is exactly how you'll combine these two statements into the possible values for the third sides of this triangle. All right, great. Thanks for watching. See you in class.